Hello students, today in the chapter number 5 surface chemistry we are going to take up the topic colloids around us, application of colloids and emulsions. So let us start with a very good thought. Hardship often prepare ordinary people for an extraordinary destiny. So if hardships are coming into your life, no problem. It is making you strong for the future opportunities as well as challenges. So learning outcomes are, so you would be able to explain about colloids which is prevalent around us, applications of colloids and emulsions. So colloids around us means whatever constitutes, whatever the surroundings to us like fog, mist, rain, these are all colloids. If you talk of aerosols, if you are taking of room freshener, if you are talking of perfume, that are coming under colloids. Food articles like milk, butter, cheese, jelly, ice cream, halwa, fruit juices, extra, all are coming around in the part colloids. Blood is a colloidal solution of an albuminoid. It gets coagulated when brought in contact with alum, because blood is negative charge colloid, and alum will give Al3 plus or Fe3 plus, Fe2 plus in case of ferric, Fe3 plus and Fe2 plus alum will give. So that will coagulate the negative charge soul of blood. Soil, due to its colloidal nature, able to absorb moisture and nourishing materials like nutrients. Blue color of sky is due to scattering of blue light by the colloidal particles of dust. That has been explained by Rayleigh's law. The scattering is inversely proportional to the fourth power of the wavelength. Lower is the wavelength, better will be the scattering, or more is the scattering. Delta formation is also made with colloids coagulation. Blood, as we discussed already, colloids are heterogeneous, blood is also heterogeneous. Four main components are there: WBC, RBC, plasma, platelets. Okay, jams and jellies. After seeing, you will be maybe feeling hungry. Okay, let us continue with the ice creams. Butterscotch, strawberry, blackcurrant. Okay, colloidal systems in daily life: jams, ice cream, mayonnaise. Okay, all you are used to that. Why sky appears blue? So blue color is because the dust particles are there in the air. Light is coming from the sun, that is scattered in all direction by the tiny molecules of air or dust particles or moisture, fog. Now, the scattering is inversely proportional to the fourth power of the wavelength. Lesser will be the wavelength, more will be the scattering. If we talk of white light contains violet, indigo, blue, green, yellow, orange, red. So, in that, the blue color is having more scattering. That's why sky appears blue, and that depends upon the size of the particles also. What is the size of the particle? So accordingly, the scattering is possible. Next is, so sun rays are coming, that may be constituting all the wavelengths. Only that blue color, which is having lesser wavelength, will be scattered more as compared to red. Red is having higher wavelength. So more is the scattering, more will be the appearance. So blue color scatters the most. That's why we are saying that sky appears blue. Okay, Rayleigh already we discussed the scattering. The scattering rate is directly proportional to fourth power, 1/4 power of wavelength. Shorter the wavelength, more is the scattering. Now, other applications of colloids, apart from that, we have discussed the colloids around us, ice cream, jellies, blood and all that. Next is rubber plating. sewage disposal, smoke screen, purification of water, cleansing action of soap, medicine, formation of delta, photography, artificial rain. These are all application of colloids. Rubber plating means sometimes we want to store the concentrated sulfuric acid in a vessel. Directly you cannot store in iron vessel. So you are using the rubber lining of the vessel. So rubber lining is rubber plating. So this is the meaning. Advantage of colloids. Colloids allow the dispersion of normally insoluble materials such as metallic gold or fats. Gold as such cannot be dissolved, but its dispersion can be made in aqua regia. So then gold can be soluble. Similarly, fats. For dissolving fats, we need emulsifiers. So we are coming to the emulsifiers. So next is colloidal gold. For example, can be used in medicine to carry drugs and antibiotics because it is a highly non-reactive and non-toxic. Pharmaceutical industry makes use of colloidal solution preparation in medicine. Wide variety of medicines are emulsions, like codeine is there, cod liver oil is there, and whatever the syrups are there, liquid syrups in terms of medicine, that are colloids. Paint industry, paints are a very good example of colloids. So we were talking of sewage treatment. Sewage treatment means there is a sludge involved. Sludge means impurity. So to settle that impurities, we are using coagulation. For that we are adding alum that will bring, or coil is the small particles to aggregates. When aggregate form, it will be heavy, it will settle down. It will settle down, then it is known as precipitation. Impurities will settle down and clear you will remove. So sludge you got at the bottom. This is sludge treatment. So this is purification of water. The water which you are coming from the municipal water supply, that is undergoing this treatment. Raw water is there, coagulant. We are adding like alum, then coagulation, mixing with huge force, and flash mixing also is saying. This is slow mixing. And then top clear liquid will be transferred here. The sedimentation will take place. It will settle and the clear solution will go here. It will pass through gravity filter and then it will be, we do chlorination and then storage and then distribution at your home. Electrostatic precipitators. To remove the dust from the air, like in the boilers or where thermal plants are there, this coal is used, their ash is produced, coal ash. So coal ash will come along there. Air is containing coal or dust particles, that is known as smoke. So smoke once enter here, there is a high voltage electrode, means the opposite charge electrode will be there. One will the electrode in the on the vessel and in the inside electrode. And when high voltage is applied, what will happen? The dust particle will come in contact with the electrode and precipitate and settle down. And gases free from the dust ash will be out through this exit. Okay, this is electrostatic precipitator. Now ink also is an colloid, is a colloid. Fine pigment, particle dissolving solvent. Solvent can be polar or non-polar. Mostly it is, if ink is organic, then it will be non-polar. And if ink is inorganic, then it will be polar. Okay. Next is related to paints. So paint protects the surface and to give the attractive look, and once it's dried, it will form a thick crust over the part you are coating doing paint. And how this is happening? This is evaporation takes place for the dispersion medium. Okay, so different types of paints are there in market. Now, therapeutical agent. Silver colloid has germicidal property. Copper colloid has anti-cancer drugs. Mercury colloid has anti-syphilis preparation. So these are used in medical application. Natural colloids, protein in muscle, bone and skin, plasma protein in drug target site binding, plant macromolecules in drug. So this is related to the medical field. So next is photography. Silver bromide coating we are doing in gelatin on the glass plate or celluloid films to form sensitive plates in photography. That was used earlier in the photography, the silver coating and all that. And blood clotting, already we have discussed that blood is negative charge, and ferric chloride will give you 3+ ions and it will be neutralizing and the bleeding will stop. Coagulation will be happening. This is known as clotting. Delta formation. So see that number of the rivers once join with the electrolyte or with the seawater, the coagulation will take place. That is the formation of delta. Positive and negative charge will neutralize and coagulation will happen. Artificial rain. See, silver iodide is taken on the plane and sprayed over the clouds, and there would be formation of ice crystals, and that may be too heavy, it will come down in the form of ice crystals or in the form of rain. So basically this charge neutralization, adsorption phenomena is taking place. Emulsion. So after discussing about the importance of colloids in our daily life and applications, and we are now coming to the emulsion. Emulsions, these are also colloidal dispersions of two miscible liquids in which one liquid acts as dispersed phase and another is dispersion medium. Both are liquid. And emulsion. Types: oil in water and water in oil. Oil in water means water is more, and water in oil means water is less, oil is more. So oil in water, oil acts as dispersed phase while water acts as dispersion medium. For example, milk cream is very less. Water in oil means water is dispersed phase, oil is dispersion medium, like cod liver oil. Role of emulsifier. To make a good emulsion, emulsifier role is very important. Emulsifier, what is doing? It is forming a protective film around the oil droplets dispersed in water. This prevents them to come closer and to coalesce. So if coalesce happen, the emulsion, it will settle, precipitate will be formed. So emulsifier provides the protective coating over the oil droplets. So then there were no contact between the oil and the water. To promote emulsion stability, stabilizes the aerated system and control agglomeration. Agglomeration means combining together. And to modify texture, shelf life and rheological properties by complexing with starch and protein components. Rheological means that, for example, the stress-strain relationship we are discussing, that after you are applying stress and what will the effect further. Okay, so more it's not in our syllabus as such. Improve the texture of fat-based foods by controlling the polymorphism of fats. So these are the role of emulsifier. Basic thing, if they ask about the emulsifier roles, you can write this only. Emulsifier forms a protective film around the oil droplet dispersed in water, and this prevents them to come closer and to coalesce. Coalesce means joining together. Identification of emulsion. How to identify whether it's oil in water or water in oil? So one is dilution test. We can take emulsion and the water we are adding to that. If water is mixes very nicely, and then it is known as oil in water. Water is more here in this emulsion. Second is conductivity. If you are adding small quantity of electrolyte and you are passing the electricity and you are measuring the conductance, if conductance is increasing, it means it is oil in water. Otherwise, if it is decreasing conductance, so it is water in oil type. Similarly, dye test is oil soluble dye. If you are adding to the emulsion, if it is soluble or if it becomes colored, it means water in oil type. If it is not showing any color, oil soluble dye is not showing any color, it is oil in water type. Next is properties of emulsions. Size of dispersed particles in emulsion may be little larger as compared to size of dispersed particles in salts. Generally, it exhibit all the properties that exhibited by the colloidization, like Brownian movement, brittle fat, electrophoresis, coagulation. And emulsification, and opposite is de-emulsification, is the process of breaking of an emulsion to yield the constituting liquids, that is, for example, heating, freezing, centrifuging. So we are removing one of the phase and ultimately it will become de-emulsifier, means emulsified state will not be there. Now applications of particularly emulsions are the same almost. The pharmaceutical industry having the preparation emulsion, liquid emulsions are there, and cod liver oil, paint industry these are emulsions. Lotions, creams, ointment, emulsions, oil and water and oil dye. Cosmetics are also emulsions. Oil drugs are also prepared as emulsions to facilitate their absorptions. Froth flotation process involves the treatment of powdered sulfide ore with an emulsion. There also we are saying the froth stabilizers, and to pine oil we are adding. Okay. Emulsifying properties of soaps and detergent used in washing clothes. That we discussed in detail, the soap action, cleansing action of soap. So soap acts as emulsifying agent. Digestion of fats in intestine is facilitated by emulsification. Fats are being digested through emulsification. Otherwise, how fat will be dissolved in our water-rich body? So what is the recapitulation? Let us see. So you know that emulsions where dispersed phase and dispersion medium are liquid in nature, and two types of emulsions, oil and water and oil. And emulsions are usually prepared by using emulsifier which stabilize emulsion by forming protective layer around us. And emulsions are colloid system and exhibit all the properties of colloids. Colloidal medicine, purification of water, artificial rain, rubber, industry, leather, tanning, electrophoresis, sewage disposal, smoke precipitator are the major application of colloids. So okay, thought for the session is hardship often prepare ordinary people for an extraordinary destiny. Thank you. Keep smiling.